This okay. Audio seems to be back now. Um, I think one of these earphones seems to be very close to seems to have very low battery. The other one is fully charged and the other one isn't. I'm not really sure what the issue is there. I suppose I'll just revert to laptop audio eventually if these die, but uh, we'll keep going as is. So, welcome back. Last week, I believe I finished off. I think the main thing was introducing the support for a special this variable within the context of this language. Took up a lot more time than I was expecting. Oh, and hey, Lord MZTE. I'm not sure if that's how it's meant to be read, but good to see you back. Recognize you from last time. So yeah, so coming pretty close to the point where I make a transition from working on this language in purely a kind of a I suppose as a theoretical exercise to the point where I'll be looking at it to actually use it for um, basically trying out new syntactical ideas for a more novel language, I suppose. Um, And the last few bits to get done, and we'll see how many we can get through today. One is the elusive else if that I've been putting off for quite a while, which I don't know why I have so many reservations about it, but I feel like it could just be a little hairier than I expect, but should be fine. Um, for both destructuring lists and objects, preventing the same name from being bound multiple times in the one expression, just to prevent any obvious problems, because there really isn't a circumstance where we'd want to rebind this same name more than once in an expression, because the earlier ones will always get shadowed by the later ones. So it will usually be it will usually be essentially hiding a bug to allow this. So we'll have an error in those cases. Um, this is, I think, just wanting to kind of show on the stream that this behaves more or less as expected. Now I can't actually remember the details of this. I might actually start off with this one because it should be a very straightforward thing to demo. If I just recall, so the logic here was, oh yes, so it's mainly, oh actually, I'm not sure if it is fully supported yet. Just the fact that, so in this will be kind of a diversion path from the likes of JavaScript where um, they have a shorthand notation for keys in object literals where you can um, omit the surrounding apostrophes. But in this language, this will actually be used for value evaluation. So, for example, I could even put in some kind of expression here consisting of a function call and an object index, and it should all work as expected. So it's just to make sure that keys in this context are actually evaluated, which should be the logic that's already there. I think I just haven't actually kind of verified it just yet. And finally, uh, so this is a bug also that I need to work to prevent declaring the same variable twice in the same scope. And finally, allowing for kind of subranges of arrays. So uh, Lord MZT think you should put Rust in your stream title so people who want to see Rust can find it more easily. Yeah, absolutely. And there are a couple of other things I like. I also want to catch up with uploading a lot of the kind of the already streamed sessions that have gone that have been kind of discarded from Twitch at this stage and put them up on another channel just so they're there for anyone wanting to catch up. And also, yeah, I probably need to do even a bit more even just promotions such as via, I think there's thisweekinrust.org, where, just for people wanting to find more Rust resources. This might be an interesting stream for people. But yeah, in fact, I might just jot that down. Thanks for the suggestion. Why not allow declaring a variable with the same name twice in scope? In Rust, you can do that, and it's pretty handy sometimes. Yeah, very good point. And it's one of these things where, there are valid valid pros and cons. In the case of Rust, you can kind of basically introduce a new binding that kind of shadows the original one, and you can even give it a new type, and that can be useful for the case of, um, for example, a very common case I would say is, you have raw data, almost like an unparsed string in your original expression, and it has it's it could be, I don't know, a number, um, you know, so you get in a number as a string from some area, so it comes in as an environment variable or what have you, and it comes in and you say, okay, this is going to be the token lifetime in seconds, but it's as a string first, and then you want to parse it, and then you want to rename it, and then you don't necessarily what like you might have already given it a good name as an environment variable, and you don't necessarily want to create a new weird name to account for the fact that you've already used the good name, and vice versa. um so it can be useful. um I suppose I'm still on the fence about the readability and the kind of how beneficial it is for readers. I like it personally when I'm writing it. It does make me feel um, good to be like, oh yeah, I can just reuse the same nice variable name that I had already. But I do kind of have an internal feeling that maybe kind of those, if values have different types, and different intentions, then maybe it is better to give them distinct names. Of course, the argument is a bit moot anyway, because this language that I'm writing right now is a scripting language. So, well, it's not that it's scripting, but it's dynamically typed, and the variables at present aren't even tagged with the type of variable that they contain. So, you could easily, create a variable, and over uh, you can create a variable and overwrite it. Uh, I suppose overwrite the value in that variable with a value of a totally different type, and that'll all be fine. Um, I suppose the main reason I'm thinking of not allowing this in this language is similar to the reassigning the same name more than once. Is that it's a bit of a no operation thing, because of that property, that even if I don't declare a new variable, I can just overwrite it anyway. Actually, declaring, let x equals something. If if x has already been defined, then the second operation doesn't actually do anything, so it's kind of redundant. And that itself probably isn't going to prevent any bugs, but even just to prevent redundancy, I'll just opt for it. But it's not a thing that I have a strong opinion on, or that I think is going to be massively beneficial in some way. It's just kind of more a personal preference at this point of time. But yeah, good call. If it was a statically typed language where or even a dynamic one where the variables are tagged with their types, then kind of the decision would hold a little bit more weight. But as it stands, it's kind of much of a muchness, really. But yeah, thanks for the suggestion. So yeah, with all that said, oh wait, there was a suggestion. Oh yeah, put Rust in the title. Okay, I'll put that down in my notes. And with that, what I'll do to start off with is jump right into this demo of, let's see, um, the this first thing, basically evaluating keys and making sure the left-hand side of the key, it has to evaluate to a string at some point, but it doesn't have to be, the key itself doesn't have to be a string literal, is the intention anyway. So what was this test file? So that test was testing what? I didn't duplicate it yet, did I? No, that's not used in any of these. So what was I testing? So this was iteration through an object. Yeah, so I'll back that up. So that was test object iteration. And what I'll do then is I'll overwrite it to introduce this new test. So the idea here, so if we go, so what was it? First of all, it was if we let a equals y, and then we said a, the literal a mapping to a. So if we, oh yeah, so this was a destructuring operation. And it was going to say if that is like that, the file extension for my language is .txt. Um, I'm not sure actually. Let me see. If it is, it's very much a work in progress name. I think txt is just what I was using for test files at the moment. I don't think the language itself, I don't think I've actually set it up to properly read from files yet. Yeah, at the moment, the language doesn't. Yeah, it doesn't even have a proper. So this again is resulting from the property that this. Oh, there goes one of my headphones already. I think. Just a second. Let's see. Yeah, that's about to expire. So what I might do is I'll take that off and put it in the case, and hopefully the microphone from the other one will catch up. So let's see there. Yeah, I think the audio is still coming through. Don't think you should put the test files in sort. Yeah, absolutely. Again, so this is more a work in progress branch. So this was more for so yeah, the structure of the stream at present at least. And so far I haven't put enough emphasis on the stream where I'm tidying things up basically. But the the kind of weekly streams that I do kind of more regularly are focusing on, I suppose, language features and kind of just adding the fun stuff that I suppose in my mind that I expect people to be more interested in. But it does mean that the code is probably a little worse for wear. It's not as well disciplined. Whereas in the in between streams, what I'm kind of calling the extra streams, where I probably take a little more time and go into probably overkill with how much I think about the things like variable names and git commit messages and things like that. In those kind of in between streams, I'll be working on kind of kind of more or less cherry picking the git commits from the work in progress branch, but committing them in a properly structured way. So again, Clippy is enabled there. Tests will, I haven't even decided exactly how I'm going to structure the tests for this. This was a big rabbit hole of analysis paralysis in all my first sessions with putting commits onto the main line. Was do I do unit test based approach, where they're kind of structured the same as unit tests, or will I do it kind of more integration test based, where it actually operates as if a normal user would. So the source files are in, or the test code are in proper source files, and then the tool is run on them, like compiled and then run on them, rather than having everything happening in memory. And then I was also thinking of, if um, if if it would be kind of somewhat in between the two, where it wouldn't be fully integration based, but it'd be kind of file driven with this kind of special file format, where you could have multiple tests defined in one file, but with a special syntax to make, it'll be almost like a domain specific language for the tests themselves. Um, so I was having a big think about exactly how I was going to structure the test actually. In the end, just keep things going, keep things moving, and not spend too much time thinking about one thing. I said I'd continue on with the kind of work in progress branch, just to, and like, yeah, this definitely wouldn't be how this language will be used in production. It would mean that it could only be used. You could only run files that are in this specific directory and with this specific name. But yeah, it's basically just for testing out the features at the moment, and implementing them. I have definitely fallen very far behind with the catch up on the main line, where I tidy things up. I'd have to do a lot of catch up. There's a big there's a lot of catch up to be done there. But yeah, that would be the distinction with, yeah. Do bear in mind that the code written in this branch isn't best practices. It isn't the cleanest, but it's the focus is more on the language features themselves, and then I'll be going back and tidying everything up as best I can. So yeah, good observation. Thanks for that. So with that all said, what I'll do is I'll continue on here. Yeah, again, just the source test.txt file. And so if this works correctly, and if I run this print statement, then what's that meant to do? So that is creating a new object, is it? Well, that's trying to do a destructuring of a tool. I don't think I might have been, what is actually going on there? So that's trying to map. Oh no, sorry, this is something different. Is this using the shorthand, where, oh, it is, yeah, this is this is the shorthand. So on the left hand side we have the key value, I think. Oh no, the no, I'm actually confusing myself with this now. In fact, what I'll probably just do is run it and see what happens if I evaluate the value A, or if I print the value of A. What do I get out here? And it's an unrecognized token. So I'd probably have to, even though this could actually be causing an issue, for the reason that even though I was saying earlier that this would be a redundant thing to add here, it could cause an issue. I actually forget what the shorthand. Yeah, because I don't, even as a shorthand, I don't allow this. The shorthand is, if you just have something on its own, then it's the key name and the variable name that it's binding to. This isn't a supported shorthand. In this case, A would evaluate to A would have to be evaluated, but I don't think that I allow evaluation on the right-hand side of the, or sorry, on the left-hand side of the destructuring. So what I'll do for the moment, in fact, I'll probably have to revisit this and figure out exactly what I had in mind when I wrote that. Maybe even watch the stream again. But another thing that I can think of that I wanted to do, so if I had X and I did have a non-string on the left-hand side, but something that evaluated to a string. So for example, a list here, and I said A0. And that should map to 1. Then when I print X, then that should be Y mapping to 1. So I'll just try that. Let's see what happens there. So first there's a panic because of what? Because, yeah, I don't actually support this evaluation yet. I only support strings on the left-hand side. I think I still evaluate them though, so it might actually just be a matter of, and we've encountered this before, where it's just that the parser doesn't allow it, but the evaluation or the evaluator does. So it could be the case that if I allow general expressions in this position, and so it would be in prop list. Now, one thing that I have to be careful of potentially is that no, that should still be all right. So if I allow expressions for keys in objects, in object literals, it will also be allowing them in objects that are being defined for object destructuring. So for that reason, yeah, this is again where actually having comprehensive tests would be very, very useful. But I'm happy to kind of, again, this being a work in progress branch, I can kind of wing it a bit, and then be more once I know how the features can be implemented, I can be more thorough in the other branch when I'm cleaning everything up. So a prop list will consist of prop items. A prop item at the moment can be a string literal followed by a colon, or it can be an expression. If it's the last prop item, oh no, sorry. So different parts of these are allowed at different times. The parser allows them at the parser level at all times, basically. So it unfortunately won't give you a syntax error if you construct this in the wrong way. I might, again, when I'm cleaning this up, it could result in more code, but I might be more strict in what I allow in the construction here. But on the left-hand side, at the moment, it's just allowing string literals. So what if we allow expressions there? And we'll see, does this just work magically by adding this rule? So I think when it's building and it's on part 48 out of 50, it's probably reconstructing the parser. Actually, I didn't take a look at the message that was being printed there. So let me see. So what I'll do is I'll change it back to what it was and see. So it's saying Norpal build. Now I'm not sure if that is what exact step that is, whether it's actually LALRPOP building the building the thing, or building the doing the code gen for the parser, or what? So unrecognized token position uh, 27, I guess. Again, another instance where I really should have much better error handling, but we'll throw everything on one line for the moment. No, that was, oops, 27. Yeah, so it's saying that that colon isn't allowed. So what's going wrong here? So prop items are allowed in prop lists, and prop lists are used for object literals, just object literals at the moment. Oh, and I think object literals are used for, at the moment, the definition for object literals is being used for both expressions and for the decomposition statements. So why then is that not being expected? So we have an expression here. For example, even if I were to simplify it to this, could it be to do with the indexing? Is that not supported yet? No, same issue. So it's not allowing it's not detecting, or this is an interesting one. I'm not sure I've quite come up against an issue like this before, where it's not clear. In fact, if I take a look at prop item pair, so that's defined in the AST. That's interesting because, oh, what's going, that's interesting. That actually shouldn't be allowing me to compile it at all, should it? It shouldn't even get to the run step, because pair is expecting a name, and name should be is being parsed as an expression, which results in an AST expression. But it's but the code generation, where am I gone now? Prop list. The code generation isn't it seems like it's compiling, but I feel like it shouldn't. Prop item pair, there's no, like, that's not being automatically converted to a string somehow. Like if I just put some silly in there, no definition found for int, yeah, that's okay. And if I put in ident there, ident will be fine, but maybe if I put in int literal, that should throw a fuss. Yeah, so this will be fine. So I had ident, and that's a string, and that would be allowed in this scenario if it compiles. I think. Oh yeah, that actually works quite well, because anyway, won't get into it now. But int literal should surely stop the compilation, because it generates an int. Yeah, expected a struct string, but found an I64. I64. So that's what I would expect. And if I put expression in here, like there shouldn't be any way that it's automatically cast. Maybe I've just maybe the runs on the right hand screen have just been slower than, like there's basically been a race condition between the code that I'm executing and the actual running of it. Yes, okay, that's what I was expecting. So there must have, yeah, must have been some race condition where I thought it was evaluating the code I had on the left, but it was actually running some previous version of it. So that's that makes a bit more sense. So now that I've changed that, first of all, I will have to update the evaluator to change how prop items are evaluated in a number of places actually. So let's so yeah, so this wasn't a case of just handle it in the code generator and it'll be resolved. I actually have to do some work, it seems. Poor me. That's very unfair. So expect a string in that position. So what is vals? So vals is the new so this is in the case of an object literal. So here we want to do the v is being evaluated from the value. Again, I'm going to have terrible names, but with the Scout's honor, not that I was ever a scout, the Scout's honor promise that I will clean this up in the mainline branch. So that will be k. Now the other, so that will be n for name, n for name, and then I'll call that name. Again, another instance of where it is useful to be able to redeclare a variable. Unavailable user 5 says, do you have any resource about writing a programming language rather than crafting interpreters or SICP? Good question, and this got brought up last time as well. It's kind of a tricky one. I have a bit of a storied history with these kind of things, and it wasn't just one resource that kind of helped me understand this. It was kind of a lot of different resources, and probably the biggest one for me in terms of learning how this stuff works was just kind of getting stuck in, getting kind of my hands dirty, and playing around with kind of lexers, token streams, all that stuff, and just kind of what can be good is if you can even like I would say SICP is a very good resource. I feel like it's a bit more understandable than the is Crafting Interpreters the Dragon Book? I can't actually remember the proper name of it. Probably our Crafting Interpreters isn't the Dragon Book, I think. Dragon Book is the compiler one, but SICP has a lot of maths. It does absolutely, but what I find about some of those books, and like, yeah, absolutely, the maths is way over my head, but what I have found for some of those maths heavy resources, such as SICP and the art of computer programming, for instance, because if SICP maths is difficult, art of programming languages is another level, in my opinion. But for me, you can kind of just skip the maths stuff in a sense. Like if there's a maths heavy bit, once you kind of skip those, the algorithms and kind of data structuring and things like that, for the most part, are relatively straightforward, and you don't actually need the maths to actually understand any of it. I feel anyway. it means, I guess, you lose the context of, yes, you won't be able to derive big O not like these huge big O notation formulas about exact uh, performance characteristics of your programs, but I've never really felt worse for not knowing that stuff. Um, I would definitely encourage, yeah, and the thing about those books as well is that they have all that math stuff right at the start when you're trying to get going and you're like, is this going to be a slog? Is this going to be more than I can handle? And for me anyway, when I've just skipped those parts, especially for SICP, I haven't gotten too far into the art of computer programming, but especially for SICP, once you skip that stuff, it gets very nice, in my opinion. Uh, did I say something controversial? Unavailable user 5? But anyway, that would be my recommendation with those books anyway, and just on compilers and things in general. I, uh, your only option is to give up. Oh, I wouldn't say that at all. In terms of like at the end of the day, some of those books as well. You you under I'm reading a C book that has 830 pages. Okay, that's a little over my limit of what I'd be willing to invest as well. So like what I would say is, for to be honest, with anything which related to programming, my advice anyway, and again, take with a grain of salt, but it would always be do projects. And with something like programming languages, learning to program, the probably the best way that I learned how to work with compilers and interpreters was actually working with an already existing. I had the kind of good fortune to be able to, as part of one of my professional roles, help out with kind of testing and debugging and working with an actual programming language that was actively being developed, and that was far and away the best resource. Like things just clicked after that. I just understood it was a bit of a learning curve still, but it was a lot less, it wasn't theoretical anymore. I could actually run this thing and see, okay, this is actually what it's doing at each step. I can see how the AST is being constructed. I can see how that then gets translated into something real. And one of the benefits of, I suppose, living in the age that we're living in is that with the likes of GitHub and all these kind of crazy, yes, there's still loads of resources and courses that are jam-packed on how to learn how to make programming languages. And I'm sure if you can understand the content from start to finish, then that'll be great. But one other benefit about kind of living in the age that we're in is that there's a lot of kind of hobby stuff out there as well. Again, there are projects like the project that I'm doing where um where it's just someone, has an idea and wants to implement it quickly, and they just throw something together. And from that basis, like that might not necessarily be a production ready programming language. It might not have all the features. It's not going to have async and await and all of these kind of things that you'd be used to. But they're, in my opinion, they would be totally sufficient for, you know, um, jumping in, tinkering, seeing how everything actually fits together, and um, and actually just playing around and seeing what it takes to write a programming language. Again, I'm not big on self-promotion, but I am trying to upload these as I go along as well, these streams. And while this is a little high level in the sense of, I'm bypassing the whole kind of uh, the whole step where I'm working with token streams and actually writing the lexer slash scanner part by hand. But you can see at least how, to be honest, the scanner and lexer, in my opinion, really aren't the complicated part. They're actually a very tedious part that you just write to get out of the way. They're not so complex or difficult in and of themselves, and that's why I'm happy to use a code generator to handle that part for me, and then that allows me to focus on how everything kind of gets composed together into this AST and how the resulting AST gets evaluated. Those, in my opinion, would be kind of the main bits um, of putting an interpreter together, at least. So if that is interesting to you, again, I'll be trying to keep up with it, but do feel free to check out the YouTube channel. It's the same, I think, username as this Twitch stream, and you can kind of follow along. And similarly, I have an accompanying GitHub repository for this project. In fact, I can, if I bring it up here now, github.com, and I'll paste this into the chat as well. And again, like I was saying, this isn't necessarily a stellar example of Rust code itself. Unavailable user 5, I prefer doing everything from scratch rather than using libraries. And absolutely, I would be the exact same. But it's kind of the difference between like that's really nice, but sometimes those things can get in the way, and like the stumbling block for compilers, for me anyway, was nearly all the theory and the kind of technical jargon, and like that you have to know so much to kind of get into it. Whereas maybe if you kind of relax your requirement, and like this doesn't preclude you from writing it from scratch in the future, but it's a lot easier to write something from scratch when you have the kind of big picture in your head, and when you're starting, what you're working towards. Whereas if you kind of go in maybe with the mindset of, I need to write this all from scratch and then learn everything as I go along, like I'm still, even as I'm writing this language, I'm still learning so much the whole time. Like there's like no end of information to learn from it. So to be honest, even the stuff you learn when writing your own programming language from scratch will be invaluable. It definitely won't be the end of the journey. Like there's, every language you write, and that's the typical thing. It's, like programming languages in general, once you write one, you're going to want to write more and more with different ideas that kind of spawn from it. But the more you write them, the easier you'll be. But I definitely wouldn't be putting roadblocks of, I need to start this from scratch. I wouldn't put those kind of things in your way. I would focus, if understanding the how it all works is the blocker, then I would do as much as I could to just kind of get past it, really. And the other thing I would say, so I suppose this is a resource if you're, if you just want to kind of follow along, and you can go into the like I have tried to be fairly good with the atomic commits, so you should be able to see, well, the first one is probably the most cluttered. It was just like, okay, I need to have something in place. But from that point, you can see how each individual component gets added one at a time, and you have these kind of atomic commits, and you can see, okay, well, that's actually, in fact, I've probably got a couple of things in there, but you can see, oh, that's where the support for a while statement came from. Oh, and or where's the actual LALRPOP definition? Yeah, so okay, so there's the actual definitions of the tokens, because that's the thing, you're still defining these tokens, you're just not writing the lexer by hand. And you can see how these things kind of slot together and how it gets built up over time. And the last bit of advice, and I know I'm probably, going on a bit about this, but it is something that, I am quite passionate about, and getting more people passionate about it. But the other, yeah, I suppose if you are very intent on writing one from scratch, I would say look into writing a recursive. In fact, maybe I'll do a stream on this at some point, because I think it would benefit people, because it's the kind of go-to for me if I'm doing this stuff. Oh, actually, again, all these ideas spinning out as I start talking. I'm a madman for tangents. But first thing to look up is recursive descent. I think is a LL programming language, I guess. And these recursive descent parser, yeah, top down. They're more or less the basic top-down parser you can do. And yeah, let's take a look here. A simple recursive descent parser, although that's probably just defining it. Okay, yeah, so it's actually defining it in terms of, actually building it up as a language. Like, I'm sure there are plenty of resources. These are probably like, I think what I'm using here is an LR parser. They're a little more complex, but if you want to get started with actually writing one, recursive descent parsers are a great place to start, because they kind of map quite well to our intuition of how this stuff would fit together, in my belief anyway. And yes, exactly. So the Lexer would nearly be, well, to be honest, the Lexer, to me anyway, really isn't a big deal. It's a thing you learn once and then you kind of forget about it. All it really is reading. You're basically, yeah, structuring your input more or less and splitting it into tokens. Like, if you're if how do I put it? For a language like, for example, for a language like Bash, even now, Bash gets very hairy, but at its simplest, nearly, the Lexer for that basically just splits words on white space. And so, your quote unquote Lexer for a very, very simple variant of Bash in Rust could be something like, input stream split on, if we have a regex, it could be on space, it could be on new line, on all those white space characters. Or you'd probably use something like, I don't know, space. And that then would break your input stream into tokens. But then, while with a regular language, you're probably going to want to be a little more sophisticated than that, and handle things like comments and things. So you might do things like, yeah, I don't know how best to explain it, but it wouldn't be the major part of writing a programming language, in my opinion anyway, or an interpreter, or any of these kind of things. It's really a thing that you kind of define once at the start and then forget, rather than having any kind of a focus on it. Again, these are just my opinions, but for example, if I was writing, I don't know what to put pseudocode, and I'm not sure what pseudocode to write this in. Maybe Python. But if I was defining a class in, or a class in Python to read to define a Lexer, I'd basically, it's nearly as simple as defining next token, and that's all your Lexer is really, is defining a token stream. And the consumer of the token stream, which is whatever is generating the AST, will usually do, basically, while, again, this isn't a valid syntax, but, while there's a next token in the I'm mixing like Python and C and every kind of a thing in here. But basically, if I said for token in Lexer tokens do something, and it'll be the do something will basically be add to AST, and then your Lexer will basically, in at least when I've actually rolled these by hand, then it generally looks like this. So it'll be more or less, I call it eat. You can call whatever you like, but the first thing will basically be eat white space. Remove all, basically get rid of all the stuff that all the white space that you encounter, because usually we're not so interested in it because it's just the stuff between tokens. So we'll get rid of all the white space. Then the next thing we'll do is we'll basically try to find what's the next atomic a kind of unit in the stream. So it'll be something like and in fact, what's my best way of describing this? In fact, it's been a while since I've even written a lecture, so I can't quite remember. Do I have a project where I did one? Let me just check my old repos, sorry. There's probably one from years ago. Scala library, did that use one maybe? In fact, that's another good place to start as well is, let's see. This could actually be, two areas to start are, if you wrote potentially a Lisp interpreter in any language more or less, and again that would hopefully get the familiarity with the lexing part. And then the other bit would be even writing a JSON parser can that's like it would more or less just be no, you'd still be constructing it, but it would get you familiar with the lexing part as well, because it's same kind of concepts. You're getting rid of the white space between the tokens, and then finding where the token starts and ends depending on different conditions. But basically, so if I take a look at where's actual meaty bit of this. So so it reads the next object from a stream, reads the next symbol for a stream. So if I were to take this as an example, so so this has to be defined after all the stuff it uses. So this is turning into a massive tangent, but basically, if we take this idea of kind of read something from an input stream that goes to read object, reading an object then basically gets rid of all the white space up until the next object, and then it checks what's the next character. And this is essentially what lexers do, in my opinion. And this is LL1, which means that you look ahead by one character, and sometimes you put it back if you don't need it, and you let some other process handle it. But basically what we're doing is get rid of all the white space and then see what's the next thing in the stream. If it's an opening parentheses, then we know that the next sequence is going to be a list. In fact, this is actually blurring the lines a bit between lexers and parsers. This would actually probably be more like a recursive descent parser, actually. But so it's eating white space and doing a bit of parsing, so it is blurring the lines. But that's why lexers to me aren't even so important, because say in the likes of this, you don't really need a separate lexer. But basically what you'd be doing is checking what's the next character. Oh, that's the character. Therefore, I'm at the start of a list. And similarly, if you had an object literal, you might say, okay, if it's a squiggly bracket, then or an opening brace, then you'll be reading an object. If it's a square bracket, then you'll be reading a list in a more traditional language, things like that. But basically, what you do is you look ahead, see what's the next thing going to be, and then you call a function that assumes that will read the thing that you're expecting. Then if it's not that, you move on and see, well, what else could it be? Okay, so it should be a symbol. So then you call the function that reads a symbol. And it's very recursive heavy. If you're not familiar or comfortable with recursive functions when you start a recursive descent parser, you very much will be by the end of it. But that's the idea. And we can even see here, actually, here's an example of so the character, when it's an opening brace, in fact, I should have unget-c'd it here as well. But basically, when we know that when the character that we've just read isn't part of the thing that we're going to read, in the sense of basically we need to put that character back. We need to undo the look ahead and then read the rest of the symbol or token or whatever. Well, no, it would be a token. Read the rest of the token as if that character that we peeked at had been there all along. To be honest, I'm probably making a bit of a hames of explaining this, but I do really feel that it's one of these things that, once I would actually start, if that's kind of a main point that you're trying to get over, even just start with writing a parser for JSON. JSON has a very simple structure, and is quite easy to parse, in my opinion. All the areas are distinct. If you encounter a quotation mark, then it's going to be a string that you're reading, and it's very well defined as to what goes in a string and what's what the escape characters are, for example. Basically, whoops, where did I go? Oh, I closed the browser window. I shouldn't have done that, but I'll bring that back up there. But basically, I definitely wouldn't get too hung up on the lexers and things. They're to me kind of the most minor detail of a language, or of a language implementation, I should say, to the point where, like I'm doing in this project, even I'm just leaving it to the code generator. I'm not even handling it myself. Anyway, massive digression there. Hopefully, everyone got a bit of kind of something that they were interested in from that. But yeah, with all that said, I'll jump back to what I was working on just there, which was getting the expressions here working so that expressions in objects in the key position of objects properly gets evaluated. So what we want to do is, and I wonder, is there some existing, yeah, here's a bit of, here's a bit of code that should do what I want. No, maybe not that one. Let's see. Yeah, so let's go here, grab that. And basically what I'm wanting to do is the name can be an expression that we evaluate. However, it when it is evaluated to its kind of final value, then the value that it evaluates to has to be a string. Oops. And so object key, or property key must be a string. So that's that, and with that there, so that'll be called k and insert kv. So that should be enough for that. 554 expression. So what's going on there? It doesn't implement display, couldn't bind object pair. Oh, I'll just have to use a different formatter for that. That's all right. And that's probably going to have the same issue there, is it? We'll see. Yeah, I think it will actually. 552, yeah, same idea. 550 equality equality isn't defined. Let's see what the issue is there. So 552 first, mismatched types. Expected a string but found that. So binding an object pair at the moment isn't using the evaluation either. So what I'll do is I'll jump. Oh no. Where was I? I was defining a pair, so I should be able to use the same thing. So I have left hand side is an expression and right hand side is, oh, and the item name should be a string, but it's coming in as an expression, so name will have to be expanded as well. So that's item name. And this will be called name. And that should handle both of those cases, but it'll probably add a few more issues. So expected reference found a string, so I should be grabbing a reference there. 575 expected an expression found a reference to a string. Yeah, because that will now be an expression, and that'll be a reference to an expression, so we can get rid of that reference too. Unavailable user 5 says tokens are like words. Yeah, more or less. They're basically the atomic kind of pieces that your AST is built up from, or the units that you build an AST from. Actually, a good I reference his repositories a bit in my channel, but see, one thing is I don't split out my 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 parser in, like, I don't have a separate section dedicated to the in fact, if I even look up LALRPOP itself, there might be an example. Let's see, test, no. I feel the sneeze. Excuse me. So, yeah, is there a, let's see, was it atom? And maybe that has some tokens defined. Yeah, so in fact, he might have some nice definitions for comments for writing a parser that I could utilize. Okay, so he's using token definitions directly, same way I'm using, even though he's got matches up here for a lot of them. I think some uses of LALRPOP actually have a separate section for the no, I'm never gonna find it. Was it maybe Oak C? Whoops. And if I take a look at the parser here, no, I think these do the same as me and use actual string literals to define the tokens and use them as is. But what you can do as well, I think, with maybe I'll just try one more. Resource, and let's see. Because I think what you can do is you can actually define the tokens kind of on their own and then refer to them. In fact, this might be kind of it. So you can actually define what the what the matches for the tokens will be, but then you can refer to them as their token names after. And this would have been in particular, I think, quite common when I was I vaguely remember working or at least reading some interpreters in C where you never really see the expressions themselves or the characters themselves. They were always referenced, it'd always be paren open and paren close and things like that. So you can refer to them as their actual kind of atomized name. And again, so a factor operation, I guess that would be multiplication and division, all these things, and this would be what it actually contains. But yeah, like it's yeah, those will be the tokens. They're basically just what the AST is constructed from. Factorial zip, am I really writing a programming language? Yes, I'm really writing a programming language. Um, uh, I feel, yeah, I know it might be a little arrogant sounding, but once I feel like if people kind of, yeah, exactly. Well, hard but possible, yes and no. Like, oh, thanks very much for that. But yeah, I think it's possibly people's perceptions of it that's more difficult. Like there, like I will admit, it's difficult to find good resources on um on how to do the thing. It's like, oh, how do I explain it? Like, it's kind of a catch-22 because when you're in the kind of the middle of it, and when you're able to when you're able to write a program language, so to speak, or write an interpreter, or write one of these things, you come to realize it's quite straightforward in the sense of that, like what I'm doing now, like part of the reason I'm actually even streaming this in the first place is because if I were to do, like, there isn't any, so to speak, inherent complexity or risky area or difficult part of this, in my opinion, in the sense of I could have done, I was going to just do this in my free time anyway. And I was thinking, well, there isn't much to learn with it in, how do I explain? For example, once you learn how to write an if statement uh, for your own programming language, and you kind of understand how the different bits tie together and how they're structured, you realize that all the other constructs, nearly, no matter how kind of complicated they seem in theory, actually kind of flow quite intuitively, especially from the point of view of building the AST. Probably the most difficult part of it to get your head around, I would say, is the recursive aspect. And that's not even necessarily a unique thing to do with programming languages. It's just, I think, a tricky concept in general. But once you have your head around this and the recursive nature, the kind of theoret and just to explain as well, I'm focusing more on interpreters as well. Compilers are a little trickier because you're, in general, if you're targeting kind of a machine language or something like that, you do have to, you know, that's a whole other kettle of fish. But in terms of just being able to write a programming language, which to me is, the most basic way would be an interpreter. For writing an interpreter, one of the biggest hurdles is, yeah, it probably is the lack of resources realistically. But it's funny, once you've gotten past some initial um, set of hurdles, it gets to a point where, there aren't, like, most of the challenges actually resolve themselves quite easily, in my opinion, at least for the simple stuff that I've been doing. I don't, again, I'm making a hames of explaining all this, but but yeah, you do reach a point where things just kind of flow a bit naturally. Uh, Man, people demotivate sometimes who have really different ideas. Like, a person asked me, what you want to do, and I'm sorry, I've probably started reading that a little too early. Am I the only person on the project? Yeah, it's a self-driven project. Yeah, but I'm probably I'd probably be impossible to work with on it anyway. I've too many kind of stubborn ideas. Um, okay, yeah. And when you say you want to write a kernel and want to write an operating system, and they say it's not possible, it kind of sucks. But it's hard. It is hard, but it is possible. That is the thing. What I would say is none of these things are impossible in my view. They are hard, not impossible. The trickiest part of them really though is just how much time they take, is what I found. Like, you can actually, like, when you read some of these books, like on compilers, interpreters, operating systems, they're like the fundamentals and how they work, you know, are, because, like, the whole idea is for them to be structured and be possible for them to implement. And it's like it is possible to implement all these things, and you can even get to the point where you can conceptualize very clearly exactly how you would write this thing in code. The difficulty is just how how long that code takes to write, because it's not just the code. The problem, one of the big problem is, you know, is that you could have, very clearly decided, okay, this is how I'm going to handle memory fragmentation, and I'm going to use the buddy system, and I'm going to use, this really sophisticated thing, and that could be, very conceptually clean and well thought out. but that implementation alone is going to take a long time, even without bugs. And then you run into, if you have concurrency issues, concurrency is so difficult to debug, to write first of all, and then to debug is a nightmare. And then you have the fact that, it's not, memory management isn't this isolated thing. It's being used in the context of a running program. And so you have to do that to kind of exercise it. And then you need to test it at different levels. So you need to test it kind of with unit tests to make sure that it's structurally sound on its own, um, as much as you can test it. But then you have to test it in the context of other programs, and then you run into areas of, okay, these, you know, to test it comprehensively, while accounting for concurrency and the fact that these are running programs with memory and all this stuff. Basically, yeah, not impossible. It's just time consuming. And it's like, I do, what is it? Like, I definitely wouldn't discourage anyone to try that stuff. I think it's so interesting, and there, you learn so much from doing them. But sometimes even just starting off and doing the first bit of a project to implement it, to, for example, implement an operating system, like even just getting started with implementing a tiny operating system that just kind of runs from the bootloader. You can boot into it and it just says hello world on the screen. You would learn so much from that. And from that, like, it's similar to programming languages, that there just comes a point where you don't necessarily have to implement all the other stuff to understand how you could implement it if you wanted to go to that degree. But you kind of get to that point where you don't need to, there's nothing to prove, how it kind of works conceptually. um but like, it definitely would be difficult to do all of those things, but doing them on a small scale is definitely feasible. I don't it probably isn't, you know it it would be very difficult to do a production grade version of any of these things, unless it's for, say, the case of a very specific embedded scenario, for example. But even so, doing the first kind of couple of parts of it as if you were going to build the whole thing, or a small version of the whole thing, you learn so much that you don't even need to build the rest. But one resource that I would actually always recommend for this, and possibly for, I haven't actually gotten to the programming section on this, but I really liked the early parts of it, is Elements of Computing Systems. So this is, I think, what one of the first people who implemented a computer in Minecraft, from my understanding, basically just followed the kind of um, stuff laid out in this book. And it's I've read the first couple of chapters. It's so nice because it gets you to, oh, I've closed the the window again, but it gets you to actually do this stuff yourself. It's not as handholdy as other books, so it doesn't do all the fun stuff for you and then give you a load of exercises at the end. It does half the fun stuff for you, and then you have to do the other half of the fun stuff. And it feels, but they give you enough information that you can actually overcome that gap on your own, and it's incredibly rewarding, in my opinion. And again, I haven't gone too far in it, but if the latter parts of the book are anything like the early parts, then I would be very confident in how it handled, because it has you handling every single bit, or constructing every single bit of a computer, from the even the logical gates. So you're building up, how would a CPU, if we were you know, you're doing it virtually, but how would we actually construct a CPU if we were to do it from scratch? So I think, is it Shotgun is the writer? Let me see. Elements of computing systems. Googling it anyway will get you the exact one you want. Oh yeah, Norm Nissan and Shimon Shotgun. I guess apologies to Shimon if I've butchered your name, but yeah, highly rewarding even if you don't get very far in it. It teaches you stuff, or it just not even teaches you stuff, but gets you to understand stuff that yeah, in a way that I've found few other resources do. Um, and got the idea for writing an operating system from a YouTuber. He's writing an OS. Yeah, well, that's kind of the thing as well. Is, you know, even just following those things, you know, sometimes that's enough. Like, and you can like just redo the same thing that they're doing and play around with their repositories and things like that. So, you know, you don't you can use that then as a launch pad for your own next project. Share the link um, if you, of YouTube. Um, I suppose to be honest, I don't actually follow too many people on YouTube. Sorry. I suppose realistically, I wouldn't be getting around to watching it, but you know, if you enjoy it, that's all that really matters. Um, Anyway, with that all said, again, I've just taken up another 20 minutes of a digression, but let's see. Continuing on here, so we have line 550. Equality isn't defined on this. So what is right-hand side keys used for? Is that just for detecting duplicates? If right-hand side keys bind object. In contrast with this, we don't explicitly. Okay, I think this is just for the key in the keys. Try and get it from the right-hand side and insert it into the props. Oh, this is for unspreading? No, what is this doing? This, that's a terrible thing to say, but what is this code doing? Right-hand side keys. So it's used here anyway. And what I do is I start off with all the keys. Okay. And then I remove them one at a time. When do I remove them? So if it's not an unspread operation, then I remove that key. Okay, yes, yes. And so I use it for the unspread so that I know what keys from the right-hand side haven't been assigned to yet. And then when I have an unspread, I can use all of those. So now the issue here is that name, in this case, and I'll have to evaluate all of those. So that those are going to be ValRefs, and those are all going to have to be evaluated. Okay, I'll leave that for the moment. Okay, but that's actually one of the last errors with it. So 543. Name. So found a string. So binding an object pair. Oh yeah, it's because name at the moment is is a string. So here, what's going on here? So we okay, so that's for the shorthand. Otherwise, we say that the expression has to be okay, so that's in the case of a single item, and we say that it has to be a variable there. Yeah, I'm going to leave that be the case. So we're going to focus on, let's see, so name is there, and there. So in this case, I could create a new AST object to say that that's a let name so I'll call that item name is going to be an expression, and it's going to be a string. Yeah, I think. And so I can change that. I think that should sort that out. No, I've given myself another error. So a colon there and expected, okay, a reference, that's okay. And then trait bound borrow is not satisfied, yeah, because of equality and hashing and all those kind of things. So what I'm going to have to do is go through all the keys on the right hand side and evaluate them, but I want to make sure that they're only evaluated once. So is RHS a map from strings to ValRefWithSource? So what I'll need to do is bind object. I'm surprised that, so object props, let's take a look. I think that right hand side props. So in the AST, if I go to the definition of an object, it's a list of prop items. And then, okay, so that's, oh no, that's a value of those. So that's already been evaluated to those values. So go to bind object. That's already been evaluated. So what's the issue here? So on line 551, oh, is my mic? No, my mic is still working, I think. On line, so these are all on this line. And the issue is just because this is now an expression, okay, instead of a string, but this is fine to contain strings. Okay, that's okay. So in that case, just need to evaluate this again. Will this result in the same thing being evaluated multiple times? I don't think so. So what I'll do is expression no, what am I doing? So val, and it was pair. Yeah, and the same way I was evaluating it down there, I'll evaluate it like this, and prop name, and I'll actually get rid of that because it should be a string now. And in fact, I probably was a bit too hasty with this. That should probably be like that, should it? Yeah. So then that's prop name. Evaluate the name. Property key must be a string. That's still all good. So now let's take a look. Expected an expression there, 566, but found a string. So yeah, now that it's been evaluated and parsed essentially. Oh, in fact, so where's name is coming from here? So one thing I could do, like, yeah, that's all right the way it is. That one I can probably, yeah, I can actually, I should be able to do it like that. So I've created, ooh, so that's not liking that. So, data moved there, because I need to clone the strings there, I'm guessing. 784, 591. Yeah, so these strings have to be cloned because otherwise it's trying to get the reference out from inside the lock. Oh, hang on a sec. No. So what's the issue? Maybe I'll just try and solve these one at a time. So 783. Let's see. So it's moving that here because it doesn't implement copy. And so data moves here. And the move occurs because S has a type string, which does not implement copy trait. Oh, I probably, yeah, sorry. I'm being silly, aren't I? 799. I think in general, this is what I've been using to get references. I must have copied something that as an optimization didn't need that reference. And that needs the original string. Yeah, that makes sense because it's not going to copy it itself, so I need to copy it for it. Yeah, that's cool. So in that case, ooh, what have I done here? Oh, I just deleted a character for no reason. So onto the other borrow messages, probably say similar stuff, I hope. No, it's still not letting me move on from here. Temporary value dropped while borrowed. Oh, I am coding myself into a situation that I can't code myself out of. It looks like lots of the other kind of lock sections. How many lines of code? Over 1,000. Oh, that's not looking good. But a lot of the other lock unwraps that I'm using. Okay, so there, that's not using a reference. That is using a reference. It's kind of a mix. I should be allowed, I feel. Like if I were to clone that inside that, I feel like that should be allowed, no? Do I have to reference that clone? Okay, so I've gotten past that one. 592, so it should be something similar for the others. Again, I really need to actually learn what I'm actually doing with Rust. Definitely I'm winging it in a lot of these streams and potentially giving people bad ideas, but you know, I shall not be held accountable for any bad Rust written as a result of this stream. Value borrowed here after a move, so it's been moved in the item name, and it's moved because a string doesn't do that. Oh, thank you, Rust. I absolutely am using a mixed case for that, or camel case. So, 568 prop name there too. Okay, brilliant. And this is probably what I was talking about, like within the first 10 minutes of today's stream. But you know, there was lots of engaging discussion between now and then. But yeah, so that's now outputting y mapped to 1. And so with that, so now I might try and deduce what I was intending with this piece. So the second one, couldn't bind object pair y, property y wasn't found in the source object. Yeah, that's what I'm saying. My source for this, which was my notes. Again, I'll probably have to go back to the stream, but it's like that doesn't make sense. Whereas if I did that, and again, I definitely wouldn't suggest anyone write this kind of code in this language that I'm developing, but Yeah, that is what I would expect. And in fact, I should be able to do that, shouldn't I? I shouldn't need that second let. Yeah, so that's all good. Brilliant. I actually did have to add a big load of implementation to get that working. That certainly wasn't a matter of just add it to the AST and it'll work. No, absolutely not. But not that strenuous of an implementation either. So we have that, and yeah, we'll add the other test file as well. So I'll commit that. In this case, what did I actually add? Allow expressions in key of object literal. Key positions known to my characters. So I'll just say keys. So in that case, the next thing to do is, do I dare the else if statement? That could be a heavy burden. Let's try with these. I really have to be careful because the last couple of streams I've really been underestimating how much work has been involved in some of the various bits. So, I made that screen very and 29 adjusted like that. But that would surely not be too difficult to implement. But at least now what I can say is, okay, I think this shouldn't be too difficult to implement. But I'm also testing a hypothesis that when I say that, it will actually result in the code being a lot more difficult to implement, possibly taking an hour or longer. So this will also test the hypothesis. So if this actually does take a very long time to implement, I will know definitively and scientifically that the fact that I said that is what caused it to take so long. So we're big into the scientific principle in this stream. So destructuring lists. So this would be a bind of a list. That's a very deep expression. I really should push that out into its, or pull that out into its own function. But we'll start with bind list. So bind list is starting with and do I say that those have to be no, sorry. So the way this will have to work, I can see this being more complicated than I expected already. So let's see. So I'll have to, I'll basically have to create a set of the values that have been assigned already, and if there is a second one, then I will deny it. So first of all, what I'm going to do as always is, well, always these days, is duplicate that. So test expressions for keys. And instead here, what I'm going to say is let A be A is equal to 1, 2, 3, and then print A, print B. And that'll give me 2 and 3 as the output. Yeah, or 3 and 2, yeah, because A got assigned last, so it means that the first assignment got shadowed. So what I want to do in that case is I want to prevent that kind of stuff and basically say that, in fact, so I have somewhere where I'm declaring a hash set, aren't I? Yeah. Oh, this could be no. I'll have to pass it into bind name. And in fact, oh, bind is going to have to be the signature of bind is going to be updated with this change as well. That's going to increase the parameter list of a lot of things. Yeah, no. This is literally because I said this is going to be a straightforward thing to implement. That's what caused this. So go back to bind list. At least it should help out with all these things. Anyway, like it'll resolve it for objects as well at the same time, I do believe. So yeah, all of these will have to take a where to put it though. So we've left hand side, right hand side, and we've already, so this will be the new one, will be a new hash set called already declared. And I'll define that on at a higher level, but it'll basically be these are the value the variables that have already been declared in this bind statement, and actually the logic of it. If I assume that all of these I really don't need to. Oof. This could be made easier by refactoring what I have into kind of a binding object. And the idea would be that because already all of this is eventually going to recurse and eventually end up in this, which is just going to do bind name. Is that the only place where it's called? And in a single bind call, it's basically going to say, if this has already been used in this statement, then, or in this bind attempt, then it shouldn't be allowed. Yeah, I suppose I'll just start with this, and then it'll the type requirements will just propagate throughout the tree. Thing is, though, this is essentially a leaf call in the tree of recursion that the bind will be enacted in. So I'm somewhat polluting all the branches along the way, or all the nodes along the way, by adding both this already declared item and also the bind type actually does the same. Like nothing cares, none of the nodes care about this until the leaf. Those three things, the only things that actually need to change from node to node and from recursive function call to the one recursive function call to the next, is the left hand side and right hand side, because those will be refined over time. But these are all going to be the same basically from the start. So what I could do is either put those into an object and pass them through, or I could add them to an instance of, like, I could make the bind calls an instant, or make the bind calls methods of that instance that contains those. Now the only thing is that I suppose kind of a structure wouldn't make a ton of sense in the way that, like, it basically would, like, that structure would only be used for the sake of getting rid of those parameters. So instead of that, they should probably just be grouped and passed as parameters rather than being put onto an instance object, in my opinion. But it would have to be refactored first anyway. So I won't do the refactoring now. I'll just do the mutilation. But there'll be some kind of intent there. Maybe I'll put a little note in the to-do list. So anyway, back to brass tacks. If already declared, can't remember what the Rust function for this actually is, but I'll just use this. So name. Okay, and so with that done, then everything that calls bind name will now need to, well, maybe I'll create a new function that doesn't have already declared. It'll just pass in or maybe I'll call this bind name in group or something. And bind name of names. No. Bind name of many. It's a tricky one. Bind name 2. I'll just call it bind name prime for now. And that will just pass all of these scopes, name, right hand side, and bind type. but the difference being here that it'll pass new hash set. How do I create a hash set? Is it new? I can probably leave that out there, can I? Anyway, let's try that. Anyway, expected, so 447, wrong number of, yeah, I'll just leave that out for the time being. 414. So I think it's something more like maybe it has key, could be contains key. Oh, can't believe I actually have to look up documentation. What? Rust contains key. Oh no, it's a Rust hash set. Oh, so it would just be a get. Wait, I don't need, oh, it just contains. Okay, I was close. Yeah, just give it that. Whoops. Yeah, so that's the code compiling again at least, but not actually changing anything. I must just check the other uses of bind name to make sure that what I'm doing actually makes sense, that it won't hide any other kind of attempts to shadow variables. So let's see, that'll have to be updated. Yeah. Wait, why is oh yeah, because it's an unspread. Yeah, that would need to be replaced. That's assignment. That could probably be that can't just use a regular bind, can it? In fact, it should, because that shouldn't be a string name on the left hand side. That should be an expression. So let me see if there are any other things like that. So yeah, assignment and declare allow expressions on the left hand side, but opposite doesn't. Function declaration, yeah, that's fine. But yeah, so I'll need to sort that. That's a bit a cheeky thing there. Allow assigning expressions with opposite. So that's that. Bind name, yeah, for the moment you're off the hook. You can do it like that. Binding a function, yeah, that's all right. Yeah, and then bind name here, we'll use the underscore version, and so that will use so bind will now need to take already declared as well. Whoops, no. Um, although, what are the calls to bind? Who calls bind? Multiple things call bind, yeah, so that's all right. It makes sense to, I might create, again, a bind underscore, which will more be, yeah, so that will be removed. So bind var, this will just pass already declared. Oh, and this will actually have to be mutable reference, because it'll then already declared will add that. Is it insert? Yeah, insert name. And I'll probably have to clone that. So that's that. I pass already declared in there. And those changes should probably just propagate throughout then. So 631 is probably equal to bind from where. So I'll probably just add already declared to all of these things. And yep. Oh no, not the bottom. That was a one I wasn't meant to add it to. Bind list, yeah, you will get a new parameter. And in fact, I should just create a macro for this. Okay, so record macro, paste, next line, that, f that, and find, oh, no, find comma, yeah, find comma, that, go back there, and then done, and end macro. So then let's, no, won't need it for that. Oh, none of the, okay, none of the rest of the binding functions were on multiple lines, so I didn't have to record a macro for that. That's okay. That's all a-okay, Jose. So then 645 is a call to bind without enough parameters. That'll go in there. That'll go in there. That would go here, I think. I've probably gotten this wrong in a few spots, but compiler will help me out there. Okay, let's see if we've knocked any errors off there. Nope, not really, down to 21. So 571 hash set new. So this will be, oh no, that'll be binding in fact, I need to be passing all these as mutable references. And so 16 errors, 571 mismatched types expected. Yeah, so that's my bad because I need to take it as a mutable reference. So 571 types different mutability. So oops. Oh no, it's oh, I need to do that with them. 519 types differ. 493. Let's see what's going on here. And bind name. Yeah, so this should be calling the new internal version. And that's, yeah, with a spread. 486. Four, five, no, 457. Add mutability there. And 418, mismatched types. Yeah, I'd say I'm gonna have to clone that because it's otherwise gonna be borrowed or moved. Bind name, expect a mutable reference. Found. Oh, can I? Interesting. 113. 4 parameters were provided there. So yeah, that'll be a couple of instances of that. So that's a function call didn't have enough stuff. 618 already declared. Oh yeah, there needs to be a mutable reference. Can't function. 486. That's correct. And can't find already declared. So someone doesn't have, someone isn't taking a parameter, are they not? Oh no. Not sure why that was an issue. And so the remaining ones are just, will there be errors in main? Not sure. But yeah, so this will be, yeah, again, there'll be kind of an inner function and an outer function. Would I put this into its own module? A special, yeah, Val will probably have to be in its own package realistically, and these get put in their own modules. This would be related to the scope stack as well. But anyway, bind will be calling bind underscore, but with the thing populated. And so hash set. Oh, I'm blanking here. Oh, it is, yeah. Oh, why does it look like that? Because it's okay, yeah, because it's using it from the package. That's not actually the type itself, is it? Yeah, so if I call it new, okay, so it's both the package and the type. Maybe I'm a little tired today, but that isn't making a ton of sense. But anyway, it doesn't have to make sense right now. Where's bind gone? There we go. So yeah, that's just plain old syntax error. And so now I have 5 errors. So 651. What's the issue here? Yeah, so that, yeah, I have to update the signature of a bunch of these now. 577. 525. So let's try those. And hopefully this will be the last error. I don't think there should be any lifetime issues. Anyway, proven wrong yet again. But that's okay. Okay, and finally, only it now. It wasn't an hour later. It was less than an hour. But yeah, the that should be working for everything now. So so I can probably do. Let's see. Let's see objects. So if I have A maps to 1, and then I map. Well, this is an interesting thing that I haven't thought of before. So if I have A mapped to A, I can actually duplicate a variable like this. I'm not sure if you'd want to, but you can duplicate a reference at least. So all of these should be 1. Just an interesting tidbit. can't imagine a functional need for it, but you know, I wouldn't rule it out either. But at least now if I do this, then that will tell me that I can't declare A again. And similarly, if I try to do it in, if I had B as an array of 2, 3, I could print A and B, C, and D. So I destructure B into C and D, and that should give 1, 1, 2, 3. Yeah, but then if I try to include A in there again, that will say no bueno. Can't bind object pair B, couldn't bind B. A has already been declared in this binding. Ah, nice, and it gives quite an illustrative error message as well, so you can kind of track down exactly what was and wasn't getting bound. Very nice. But anyway, I think I have proven scientifically that my words do alter reality. So let's see, git status. Yeah, I want to get rid of that extra white space. Oops. Whoops. Get that and git commit. Prevent. Excuse me. Prevent what? Prevent names from being bound. Prevent name assignment from shadowing. Or yeah, I think that's all right for now. And so with that done, that is another item off the to-do list. That was under assignment, under destructuring. And so let's see. Dare I say it? Dare I risk the cosmic repercussions? But I think this should be fairly straightforward. I don't think this would take more than 10 minutes to implement. Let's give it a go. And then I'll leave it there because yeah, these last bits should be possible to wrap up in another session. So here we go, 10 minutes to allow assignments with the shorthand to be assignments with the arithmetic shorthand to be done to use expressions. I'll get a test in there as well. So that's test assignment shadowing. And a test for this would be let a is equal to 1. Oh, actually, something this language doesn't support as well is list depending. I don't think so. Well, you can concatenate lists, which kind of does the same thing, but actually, yeah, maybe that's sufficient. So if I do plus equals 2, and what actually do I have list depend, or do I have concatenation with the shorthand out of the box? Let me see. So let a is equal to that, or let x equal that, x plus or equal to 2. So I'll print a, and that should be so when we allow this, oh, is that even going to build? That shouldn't build. No, it absolutely won't. No, but that's the test that I'll be running. So this is the thing that's actually being tested. This is just a curiosity that I wonder if it works. But anyway, into the evaluator. How many errors? 3 errors. That's a good start. That means we might get it done in the 10 minutes. So let's see. 139. Operation assignment. Yeah, that's what would be expected. Eval. So I'm looking for a lock unwrap. So one similar to what I've used before, where I'm getting a string out of it. Prop name. Yeah, so instead of name, it'll still be LHS, but this time it'll be coming from yeah, I'm shadowing, even though I was saying it probably isn't. Yeah, I wonder if it is a best practice, but I've been making full use of it in this project, but I'm going to forbid it in my language. Do as I say, not as I do. So property, oh no, that doesn't need to be a string. It's just that, yes, so it's that bind name now needs to just be bind. And instead of I'll have to do, why can't I go back? Oh, because I overwrote that. Yeah, so what I'll have to do is I'll have to evaluate that expression and so that shouldn't be name anymore as well. That should be LHS. And there, I don't think I'll need to bind it again, actually. That's another thing. So it'll be eval expression and it'll be LHS and right hand side, and apply binary operation. And now here would be the tricky thing, is putting it back in the place where LHS is. So LHS is a ValRef with a source. So I want to basically replace the value in the arcmutex. So in this case, what do I do? I haven't actually had an expression like this before. So let's see. I would take the left-hand side and I have to lock it, unwrap it, and say that that's equal to V. Does that make any sense at all? So LALRPOP is complaining about, oh yeah. Yeah, I think it's usually LALRPOP generating the parser and stuff that's actually eating up a chunk of time here, because when I don't change the parser, it does get a lot faster. Method not found in ValRefWithSource. Yeah, that would have to be .v. Yeah, because now it's on step 49, whereas usually it kind of takes a bit of time on step 48. Okay, so that does work. Very nice. I mean, of course that works, because I definitely knew what I was doing. But having said that, let's take a look at the test and see if the output actually matches what I would have expected. So this should ideally have a list containing just 3, and it does. Yeah, the list is preserved. Yeah, list containing 3, and then yeah, so that's basically all I wanted to confirm. Then this one, let me see. So this is actually, that's an interesting thought, is that every time I do an assignment, what is being done is that it binds a new, it creates a new binding. So a new area of memory is being created for the variable. And that's being done for both variable declarations and variable assignments. But realistically, variable declarations, only variable declarations should be allocating a new section of memory. The assignments should be overwriting the existing declaration. So maybe maybe I will no, oh wait, no, so that was the 10 minutes. I did it within the 10 minutes, definitely. No, it's 1 minute past the 10 minutes, but I got there. So yeah, but that gives me an idea for something else. And then does this work? So so this is a list with the value 1 and the value 2. Yeah, so that works with lists. Nice. So git add p that, and I git commit all of that. So what is the piece that got added here? Allow operation shorthand on expressions. Cool. Did that add all of them? Yeah. So that's an interesting thought, just that declarations should or sorry, assignments as opposed to declarations should actually overwrite the value at that position. So let me see, where would that be? It's not in the scope section, is it? No, it's in bind name that we just saw. Yeah, and the idea here is that if we have a variable, oh, I have support for const. I shouldn't sound so surprised since this is the language that I'm writing, but I'm surprised. I forgot that I I'd added that. That's okay. But yeah, assignment. So so it is in scopes assign, and so the idea here is that, yeah, it actually unlocks the scope and inserts it there, but I don't actually need to do that, I don't think, because I should be able to instead so it gets the key value, and location, and I should be able to do the same thing. So location v lock unwrap, and oops, v, and do that. Maybe. Let's see if that causes a fuss. Expected a value found a ValRefWithSource. So maybe I can, oh no. So let's see, the location stored in a scope. Oh, interesting. That's a bug as well. I'm not sure how that actually made it through, but a scope stack doesn't actually. Oh wait, no, it does. Oh wait, and it's initialized with. No, that's all right. So scope. So what's it doing here? So locking the scope. Which is the current kind of scope layer. And each scope is a hash map from values to ValRefWithSource, yeah. And a ValRefWithSource is a pair. Let's see. Where is ValRefWithSource defined? So it's a pair V and the source. So I'm attempting to overwrite the value. Okay, so I'd have to overwrite both of these individually. I don't like that so much. Although what I could do, no, I can't because of the function calls, but oh, it's not ideal. I could do that. Um, replace the value and the source with it, and the source that's there with it separately. No, I don't like that. No, sorry. Let me see, what was there before? Was it so horrible? Maybe what I could do is unlocked scope, get key value. Let's see. So that's a scope, and map strings to yeah, realistically, that would ideally be tied with that source. But that source itself would be behind an arc mutex as well. This is kind of a shortcut. Yeah, I suppose I'll add a little note here. The source. not sure how. So realistically, yeah, this should probably be defined as, and again, this will be ValRefWithSource instead, but this should be probably defined as mutex value, where that's the source, and it would be that would be ValWithSource, and then the whole thing would be ValWithSource. I don't know, not sure what the name would be, but they'd basically be stored together. I'm not sure how much work it'd be to refactor everything to use that instead, but like it shouldn't affect the correctness of what's there now, specifically because the new assignments are overwriting old ones instead of actually I just realized as well, I'm sidestepping the fact that Rust isn't garbage collected. So I'm creating all these references and not actually cleaning them up after myself. That is an issue. And I know nothing about garbage collection. I may have to learn about garbage collection, but as it stands, yeah, that is an issue. I have to figure something out about that. But yeah, this whole thing that the source of a value isn't, it is kind of stored beside the value and rather than next to and nested, like it's basically the specific so it's the arc mutex is stored, or the arc mutex of the value source is stored next to the arc mutex of the value itself rather than in the value's own arc mutex, if that makes sense. And that shouldn't affect correctness because we're just replacing bindings when we do assignments. But it does mean that, first of all, we can't do the basically the correct version of this, which is to unlock it and override the value within the binding or within the arc mutex. And it could also have subtle ramifications down the line as well because of this just kind of structural inconsistency, or basically because it's not structured the way it realistically should be. But yeah, I'll just put it in a to-do comment for now. That should ideally overwrite the value at instead of introducing a new variable with a new line. So what would be a good approach to garbage collection? I know I feel like the typical one is, I suppose there's reference counting and there's just tagging, and then every so often the garbage collector runs and just says, hey, is it still possible to reach this item anymore from any place? And if it isn't, then it gets rid of it and frees up the memory. And that's the theory anyway, how that will be implemented and implemented efficiently. I really don't know. Go's garbage collector works by scanning. Scanning in what way? Pilfers. Apparently, Go's garbage collection has gotten very good as of late. Like the types of applications I've worked on, I've never really, I'm not in game programming or anything, so garbage collection has never really been a massive performance issue for me. So it's not something I've invested too much time in, but that's going to be my downfall now. So yeah, but I think, have I heard that as well? That it's scanning stacks, pointers, globals, and checks for existence or accessibility of them. Okay, yeah. I must look into it a bit more deeply. Like realistically, I'm very unlikely to do anything as sophisticated as what Go's doing. This will I'll probably just be focusing on something that works. Yeah, um, yeah. Luckily, we're able to be somewhat ignorant of all the nitty gritties of the garbage collector. But yeah, it'll be. I wasn't necessarily hoping to write a garbage collector as part of this, but it makes sense. Like I don't know, I was somewhat imagining, oh, would Rust just magically handle this for me? But of course it wouldn't, and I don't think it would matter what uh, source language I. Oh wait, no. If I used a source language that already had garbage collection itself, then I could just piggyback off the fact that that language has garbage collection, and that would make this part of it a little easier. But then I wouldn't have the nice safety around concurrency and things. So I think it's worth the trade-off, and it'll probably be interesting to write a bit of a garbage collector here anyway. So I'm not going to beat myself up too much, but yeah, this is certainly interesting. So should ideally overwrite the value stored in the variable instead of introducing a new one? This isn't possible at present with the current structure of ValRef with source. See the comment above, ValRef with source for more details. And I'll add a to-do comment as well. Very unlikely to be something I'll be looking at in the stream, but will definitely be something that will be essential if if this is going to be used as a basis for a production ready language. But to do will be add a garbage collector. Didn't think I'd be writing that down on this to-do list, but there we are. Oh no, I lost my terminal. So this is Norpal. No, did I have it as scale line? Yeah. So that and that. Add to-dos around structure of ValRefWithSource. There we go, and push that. And with that said, maybe I'll consider, well, first of all, that's that assignment done. So that's assigning to expressions with that. So that's that out of the way. Consider refactoring ValRefWithSource to be this awful monstrosity of arc mutex value. Now, it's not necessarily going to be a tuple. I don't think it will be, but it'll have to store the source value beside itself rather than within the mutex rather than beside the mutex. Pilfers, if you feel like it, I'm 100% interested in hearing the language pitch overview, structure, features, compilation process. Yeah, absolutely. So, well, first of all, thanks very much for your interest and welcome to the channel, Pilfers. So, yeah, apologies to anyone who's heard this before, but the idea here is, so what I'm working on currently is Norpal, not a real programming language. It's a research language that I'll be using to basically play around with syntax for a more production-ready language that I'm designing, which will be called Laurel. And Laurel will, the intention for Laurel is to effectively replace Bash. Would, if I had to sum it up, I'm not sure how, realistic a goal that is, but the rationale behind it is that Bash itself is yeah, ambitious, exactly. But that's just to summarize it. I'll mainly be using it for my own scripts. If other people want to use it as well, that's great. But that's just kind of the idea more than anything. And the idea is that Bash, as much as myself included, but people like to kind of complain about it, is very ergonomically friendly, or is very suited to gluing programs together and calling programs and chaining them together and whatnot. The syntax itself can be a little kind of unusual, a little clunky at times, and especially its handling around white space and things like that can make solutions a little unintuitive, I suppose. And so the idea with Laurel is to try and keep the ergonomics of Bash, but make the semantics and the structure around it just a lot more uniform and a lot more, I suppose, conforming with what we're probably used to in a lot of modern C-derived programming languages. So, curly braces, if statements, while loops, all very structured in similar ways. And instead of having, for example, globbing at the language level and this special IFS syntax for special string breaking at the language level, instead, a lot of that will be handled at the kind of level of regular functions and things, but the idea would be that it would have special semantics so that you could still write things like calls to programs very easily. Now, I'm not sure if I've actually delved in too much into how that would actually look. I'm not sure if I've mentioned that too much in the stream so far, but to take a look at what that might look like is that um, I am thinking of continuing on with even though I've had issue with it in the past, I am thinking of continuing on with the idea that in this new language, that variables will start with a dollar sign, and while that's not maybe not nice, so to speak, it does mean that we can then, I suppose there are a few ideas in this language, but one idea is that regular, kind of similarly to Bash, regular words matching a certain set of characters that would look like a variable in other languages, if they don't start with the variable prefix, whoops, then they'll just be interpreted as a string. And, you know, as I was hoping to introduce this maybe a little later, but I suppose as good a time as any, is one of the ideas is that you can just put parentheses after any string. So this could be a string, string ABC, or a variable ABC that contains the string git, or it could just be git on its own, because this without the variable prefix will be interpreted as a string. This will basically start this. If a string is followed by brackets as opposed to a function call, then that will actually start a process with that program name. And then the inside of that, so it'll make it look like, it'll still look like Bash and still have a lot of this similar semantics, but it'll look like a lot more like regular programming, so to speak. So, I could go git clone HTTPS. If there are certain characters in the string, then I'll still have to probably escape it and stuff like that. Uh, but then, we'll have that, and then that will return an object potentially. So I don't have to be poking around in special environment variables that could get overwritten if I run another program. This will just be a regular object populated with, exit code, stuff like that. And anyway, so those are just so is it like let dir contents? Yes, exactly. So, well, that's one interesting area, is just exactly how the piping operation is going to work. So yeah, to copy your example here, so we'd have let dir contents is equal to ls hyphen IOA. Now, first off, this would return the entire, for example, this would return the entire process kind of result object. So the result object could probably contain a few things. So it could have the exit code, for example, and it could have maybe the captured standard out if we're capturing it. Now, this is one area where it could get hairy, and I need to put a lot of thought into it. But by default, these things could get captured if they're not output by default. But then if we decide to pipe it, it could be something like ls, and then that's piped to like, yeah, I'm still not exactly sure how piping will work. I am eager to get some kind of a mechanic around it. One thing that I would like to have a bit more thought around is just the fact that pipe by default just maps standard out of one process to standard in of another, and that works 90% of the time. But I feel we do sometimes encounter those other cases regularly enough that it would be nice to have some kind of handling of, maybe smarter handling of that. Like, one nice thing that I would like if it was maybe more integrated into Bash would be if we had, kind of natural named pipes. So, that could be maybe piped into, you know, a new named pipe called ls output, and then ls output could be, piped into multiple things, and we could, you know, I could say even, that, file descriptor 1 gets piped into ls output, and file descriptor 2 gets piped into ls standard error, and I can handle them properly independently. But the mechanics of exactly how to, in fact, one thing I think I was thinking about that was that, you could use some kind of a syntax to introduce, because the thing about pipes is it kind of abstracts it. You almost think because things are listed sequentially, that for me for a long time I just naturally assumed that, okay, this process runs, the output then goes to the next one afterwards, but they're actually all running in parallel, and the streams are running through them. So a syntax like this that nearly highlights the parallelism as well is something that I've thought about. But again, the nitty gritty, and a lot of this I'll be thinking about as I'm going along, and that's the reason for this basis, is to even figure out what's even possible, because even something as simple as, you know do do I want to allow you, or do I want to allow the language to do this unadorned? I don't necessarily want everyone to have to type strings around, -v. But then the issue there is, you know, is hyphen one, is that the expression 1 minus 2, or is it the parameters 1-2? So all those kind of considerations and figuring out exactly what goes where is part of why I want this basis to explore those things, and I want the minimal feature set so that I'm not, for example, stepping on the toes of any other language features. Loads of helper methods like pipe, fork, split. Yes, absolutely, and split will be such an important one to counteract the idea of, for example, IFS. So the idea will, could be that, I think so many people have dealt with the idea that, okay, I take my parameter list as this weirdly formatted array of strings, but to access individual elements and put them back together. So if I built up, for example, a list of params, 1, 2, 3, like, and they were meant to be individual parameters, but they had spaces in them, for example, and I had 2, 3, and 4. Like in Bash, I'd have params, maybe 1. I'm actually not sure how this would work in Bash, but I could have something like that. And I can't have spaces there because that would mean something different. And then when I go to run my, for example, ls, and that's meant to be a file called 2.3, and those are meant to be 2 other files, and then I go params, and it's a bit of a mess, or I could do that, and it's still a bit of a mess. Whereas in this new language, I would have let params, and when I call ls, I can just do params, and I can destructure it so that this is then this is this list, and those arguments are all interpreted correctly as you'd expect. And then split will be used to do the reverse. This is actually super interesting. However, do not envy the syscall code going to have to write around forks and things. Yeah, that could be hairy. I'm not sure how exactly I'm going to do all that, but backticks, single quotes, double quotes could make them all mean different things. Well, that's the thing, is that backticks, single quotes, and double quote. Well, single quotes and double quotes, I do have some grievances with those over the years, in the sense of, for example, the way with JavaScript and Python, how they don't have they're not actually distinct. They're more or less interchangeable, and it just depends on what data you want to encode. And then you've other languages like Bash and PHP, where one allows interpolation and the other one doesn't. I find the PHP and Bash versions a little unintuitive, so I'd actually probably just allow one syntax for declaring strings, kind of like how, say C and Go would say, strings are double quotes, characters are single quotes. I won't actually have a distinction between strings and characters in this, so is the intention anyway. So I might actually just use it for something totally different altogether, or maybe not even use it at all. I'm not sure. Like, I don't necessarily like having two ways of doing the same thing. But backticks, again, yeah, because it won't even be necessary, like processes by or these processes by default will probably be capturing their output. So backticks and things won't, and dollar with quotes won't really be necessary for that. So though, that frees those up, and that means that things like that could maybe be used for mathematical expressions. Again, things which, unadorned could, you know, could mean that there's less flexibility in the actual string naming, for example. But yeah, I think it would actually simplify a lot of things, and that simplicity would open up the doors to a lot more advanced features. But again, in a simple way is the intention. Um, yeah, for the sake of the parser lecture, the syntax here needs to be extremely simple, very verbose. Um, yeah, and Go supports backtick strings for multi-lines. Yeah, that's another approach. Like, I'm probably not too against the idea of even just having allowing regular strings to span multiple lines and capture the new lines in between. I don't really see like Bash actually allows that, ragging on Bash, but Bash allows you to the default strings allow multi lines, so don't actually see any inherent problem with that. I probably would go the JavaScript route of backticks for interpolation and uh, uh, single apostrophes for regular strings, even though, but anyway, that's a digression. But yeah, in terms of the syntax, the intention, not just for the parser and lecture's sake, but for the human reader and writer, to make the semantics very simple. Because that's one of the things, is that you could be like, Bash is so complex in the sense of, you could be writing a thing and you're like, you're writing regex, and you just have to surround it with that, because you don't know what characters will get. You know, if I do that, you know, I'm experienced enough now to know that, if I did this on its own, Bash would turn this into a glob. Um, but this wouldn't need to be surrounded with quotes and things like that. Oh, I have to. Sorry, 2 seconds. I need to charge the laptop. But yeah, the idea is to make the semantics so easy as to, it won't be kind of you can nearly call Bash's syntax kind of exception based almost. 1 second, have to bring dog upstairs to my office. I'll wait until you finish the sentence. Oh yeah, so if sorry, I'll make it quick. So if Bash is kind of exception based, where you have like, okay, I need to know that wildcards have to be escaped. I need to know that, X, Y, and Z has to be escaped. If there's a dollar, and dollars usually don't have to escape the variable name after it, but if it uses special characters, then I have to put it in braces. I don't want any of that. And the idea is that it'll all be kind of very regular and very simple, and kind of hopefully defined in terms of, like, it supports the alphanumeric range, capitals and lowercase, and if it allows an extended character range of characters beyond that, that it's very easy to identify either via inclusion or exclusion, maybe a handful of characters. So you can either say, it your identifier in this language can contain uh, basically any character except white space and maybe these handful of characters, or else the other way, it can only handle alphanumeric characters plus these 4 or 5 regular, or handful of regularly used special characters, is the idea at the moment anyway. But again, this is the whole point of this basis, is to explore that syntax and see what's even possible. So anyway, sorry, very long sentence, but I'll leave you take your dog upstairs now. Thanks very much, Pilfers. So anyway, big load of digressions today. So but it's very I'm very pleased to have people participate and join the conversation with me. This is stuff that I'd be doing on my own anyway, but it's nice to see interest in it. So with that all said, that more or less, yeah, brings me to the end of today's stream. Let me just kind of check out again where I'll undo all those changes, and I'll just check out where everything is at the moment. So in terms of the to-do list, because I'm very close to getting to that point, maybe 2 more weeks before I start diving into, again, it'll be work in progress branch, because I'm currently on a work in progress branch, but looking into actually researching the Laurel language. So yeah, next week will be else if, subranges, prevent declaring the same variable twice. if I hadn't done that similar feature where you can't bind a variable twice in the same expression, if I hadn't done that earlier today, I would say that should be fairly straightforward. But given that experience, I like to think I've learned something from it. Let me think. Preventing declaring the same variable twice in the same scope. No, that has to be straightforward, because as opposed to keeping track of all the assignments being performed in a single binding statement, these assignments could be totally independent. So all you have to do is check, is it already? In fact, I could nearly do that now. I think. I feel like that would be very straightforward. I could put it into the declaration function, and all it would have to do is, before the function actually, now that would just be a simple way of doing it. It could be susceptible to Toctow, like time of check, time of use issues, because I wouldn't have atomicity around the checking whether the variable is already declared and then introducing the next one. Oh, but I would actually, because scopes are in a mutex. So actually, I would have not necessarily atomicity, but I would have protection with the locking mechanism, so that's protected. So in the declaration, I could just check, oh, does this name exist in the current scope already? If it does, then that fails the binding, because it's a redundant redeclaration, and it could, that redundancy is actually a really, like, redundant checking for redundant operations is such a good litmus test in in languages. I think we're seeing more and more of it. Like a hugely useful one is in Go, that it will say, okay, you've assigned this variable, but you've not actually used it. In effect, this variable itself is redundant, and it's a very good flag that, you have an opportunity to just either get rid of a variable, but what's more often the case is you've introduced a new binding in a narrower scope, and that you're not actually pulling out the value into the outer scope like you expect. So, oh, good to have you back, Bill, first. So, yeah, basically just finishing up the stream there, just recapping what's left to do, really just a handful of things, and then maybe week after next or after that, I'll be getting into the initial groundwork of the actual Laravel programming language. So really excited about that. Again, it'll be mostly research rather than the final production ready implementation that'll be getting started, and I will have to dedicate some time to tidying up the current code on the mainline branch, and maybe looking into implementing a garbage collector. But yeah, that all relatively I would say straightforward stuff um, for the last few features of this. So, if all going well, I could even be starting looking at the implementation of some of the Laurel features next week. Who knows? So anyway, thanks very much for tuning in, everyone. It was really nice to chat with so many people and have so many interesting conversations on a load of different topics. Um, so, oh, thanks very much for the follow-up, Pilfers. And yeah, to anyone else who's interesting, the intention is to be kind of streaming this weekly. So, if you are interested in the subject matter, do feel free to follow. If you feel it's a little above your level in terms of the coding, I will be uploading these on a separate channel, kind of on a more persistent basis. So hopefully, people will be able to use that to catch up again. And similarly, there's a GitHub repository for this. I think it might be linked in the description. If not, I will link it, and feel free to check that out too. So yeah, again, thanks very much, everyone. Really appreciate the interest, and yeah, I'll be speaking to everyone next week. Bye.